In 2015 or so, I made a video about the alignment of all of the planets in our solar system as people were talking about it. They were discussing its effects, whether they exist or not. This video is going to be a lot like that one, which has been lost to time because it was erased because YouTube took down the channel that it was on. The planets lining up, an alignment that might affect Earth or the solar system or your chakras and maracas or your star charts or alien invasions. I want to point out that depending on what definition you're using, these alignments can and do happen every 13 trillion years, every 396 billion years, 400 billion years approximately, 1,543 years, or every 40 years. I'm not going to be discussing what you have learned from another web page or YouTube channel or discussing it. I'm going to be talking about actually lining up the planets and what effect they would have at all. Not just that you can see them at the sky at the same time and that's good enough. Because it isn't. Having an ego or Earth-centric view of it when you're talking about gravity is meaningless. Gravity depends on how massive something is in matter, how much atoms are in it, how heavy, and how far away it is. Gravity, at that point, is a static pulling force. Unless you're dealing with something like a dynamic rotating mass of two black holes, we are talking about the same thing here. A static mass force, not dynamic. If you insist on invoking some special version of reality that doesn't exist, where it is dynamic, stop watching the video right now. There's no point in us talking. We can't be friends. Well, we can't talk about this because we're not using the same basis for reality. Tidal forces are the dynamic forces upon things due to some manipulation of objects that have a static gravitational field moving relative to each other. That's what we're talking about primarily. The more mass, the stronger the pull. The farther away, the weaker the pull. The lower the mass, the less pull. The closer they are, the more effect they can still have. The further away, the weaker the pull. Gravity drops with the square of distance, but tidal forces drop with the cube of distance. For example, if you have two objects that are, let's say, orbiting each other. Let's say it's Pluto and its moon orbiting itself, even though apparently we're not allowed to call it a planet. If you move them double the distance away from each other, you'll get 1/4 of the gravity effect, but you'll get 1/8 of the tidal force effect. And in some cases, the distance may be increased to the point that there is no tidal force. The moon is smaller and closer than the sun. The distance it is from the Earth versus the diameter of the Earth versus how heavy the moon is compared to how heavy the Earth is means that it has, well, it doesn't have gravity effect on the Earth that is consistent all over it as much as other people might think. Tides are caused by the difference in gravitational force, or gradient of gravity, not the static gravitational force. For instance, the sun is very massive, very far away, but by the time gravitational field from it comes to here, it's evened out all over the place. Its effect on the Earth is almost identical to its effect on the moon. Not absolutely, but very close. Now, the fact that the Earth rotates on its axis once every 24 hours, which is mind-bendingly slow, means that at that distance, let's say water on the Earth shouldn't be able to move as much as it does, but it keeps moving following the gravitational pull. It's dragged by the gravitational pull of the sun and of the moon. The moon also orbits the Earth, creating a kind of conundrum where this has interference effects, which you can predict, and they're called tide charts. We can measure these tides and determine how influential or non-influential each is because they don't happen exactly the same time. But I want to point out something very important. It's not how high the tide is, it's how low it is. We can think of it in many ways, but one of the examples people give is if there's a high tide on the nearest side to the moon, that's because the moon's pulling on the water. And if it's high on the opposite side, it's because it's pulling the Earth away from the water. But what's really going on is, what's happening is that on the sides where the moon isn't, and it's at right angles, it's pulling all of the water away, creating the lowest tide possible. The water has to go somewhere, and it ends up going mostly towards the moon and also partially towards the other side. Again, we have a gravitational gradient that has more dynamics to it because of the moon. With the sun, there's also something like that, but again, it's not where the tide goes high, it's where it goes low. And because the moon can be at a right angle to the angle of the sun, effectively, you can have a high tide from the moon and a high tide from the sun not happening at the same time and get a neap tide. They can also be aligned pretty closely and create this effect, or push-pulling, where the moon and the sun are on opposite sides of each other compared to the Earth. Because we can measure these, and we can also figure out by using these as examples what effect hypothetically we would see from the planets, we can actually do the math for them. Now, this is where I ran into a couple of problems. Not with the planets, or even with the moon, but with scientists not shutting up and actually giving you the numbers for the sun. And the major thing was, most science papers want to talk about the tidal forces, not the actual gravitational pull that causes them. Many of them wouldn't list it. And in fact, some people had their papers graded down, if you found it, or had blistering commentaries from other scientists telling them that you've done a terrible thing by not telling us this, and then they didn't do it either. In 2015, I couldn't find anybody who would list the absolute gravitational effects on Earth's surface from all the planets and the moon and the sun. They would tell you ratios, they would give you glittering generalities, but these bastards wouldn't just list the numbers that they obviously had. Well, it's left to the student. No, it's not. Since that time, many people have realized that snooty attitude of not telling you the answer in the first paragraph so we don't have to read your damn paper has caused more trouble than it's worth. Shame on the scientists. And again, that's one of the reasons people have a problem with science. It doesn't just tell you the answer, it tells you, no, this is how you do the figuring out. And that's very useful. But I need to know whether or not the world's coming to an end, not how to figure it out and spend 6 years in a college class with you. We do not bow down to you. We demand from you. And if you do not like that, shut the fuck up and get off the internet. Okay, that's the end of the rant. By the way, if you came here for answers, they're going to be listed in the video. You don't have to watch the video. The whole video is one big single paragraph answer. If we compare all the planets, the sun, and the moon to each other, and use the moon unit, not Zappa, as our reference point, we will now use the moonit. We'll also use, for some scary reason, Neptune. Yeah, because Neptune rounds off to a really nice small number, and the moon rounds off to a really big number that's a good ratio. Let us begin. The absolute gravitational effect of the moon on Earth, we're going to call 1. And its tidal force are going to be called 1, because we're separately analyzing them. If we use the moon as a unit, the moon unit, as our number 1 value, Neptune, goes to 0.00001 unit, Neptune unit, for the tidal force. On the ratio for absolute gravitational effect affecting a person at sea level on Earth, that's what this is based on. It's actually a smaller difference, 0.00001 moon units. Now, because that so beautifully lines up, we're going to compare tidal forces based on Neptune. Mars is 1,000 times more effect on tidal force. Jupiter, 6,000 times. Uranus, 3 times. It's further away, heavy, etc. Jupiter's massively heavy. Saturn is 200 units. Mercury is 300 units. It's closer, and it's dense, and that's it. It's just closer. Venus is much closer. It's similar size to the Earth. It's 50,000 times more intense on tidal forces. That being the largest one, it is still 0.00005 moon units of tidal force. Now, on gravity, just straight gravity, which again can't cause tidal forces in most cases at all. We're just looking at the static, for a millisecond. Bam! meaning if they were all on alignment and we were just saying how much pull they have rather than dynamics. Okay, here we go. Assuming a spherical cow. Let's move on. If we use Neptune versus Moon, we get 0.00001 units. Neptune as a Neptune unit, the Nunit. Mars is 20 times more intense. Jupiter is 1,000 times. Uranus is twice as intense. Saturn is 70 times as intense. Mercury is 8 times as intense. And Venus is 600 times as intense on static gravity compared to the Moon. What about the Sun? In Moon units, the maximum tidal effect of the Sun is 0.4, 40%. It's actually 0.41 approximately. Its static gravity effect on the Earth is 160 times more intense. But again, the dynamic change is much tinier, like on a ratio of like 300 to 1, simply because it's affecting the far side and the near side of the Earth almost identically. Because the difference between our 8,000 mile across Earth compared to the 160 million mile distance to the Sun, it's not got a lot of differences there. The differential is the important thing. But I'm going to include the static force because it's so much bigger. So let's go on. In Moon units, the maximum combined gravitational effect of all the planets on our planetary system, if they were in perfect alignment to cause the maximum amount of torsion on the Earth, static torsion, which is the worst case scenario, combined gravitational static force, is 0.017 Moon units. It's almost non-existent. The dynamic energy, the tidal force, which is what would be putting torsion on the Earth to cause torsion on anything, the Earth, or even the solar system, somehow. 0.00057, basically 0.00006 Moon units. These are numbers that are so vanishingly, mind-fuckingly small that they're not worth paying attention to. But how can we lower them? Down to a continent, divide it by 20. Down to a human, divide it by so much it just disappears. Effect on human beings with all of the planets combined has no effect. More and more of no effect, the smaller you get. Down to neurons, you get literally no effect that could possibly be there. Cells, molecules, atoms. There's more of an effect on your house's shape than on your chakras and maracas. They do not have an effect because they don't have a measurable gravitational effect, unless you're assuming some other, somehow magical effect that has to be more important, which is fine. But that doesn't fall in the realm of science, or even pseudoscience. We call that bullshit in the real world. Is it possible for an alignment like this to harm the Earth? Let's look at direct effect. The largest height variation in sea level, which is actually not caused by the tidal force, it's actually caused by a scooping effect from the ocean rushing in, because again, it's dragging the oceans and all the waters in a circle every day as a cumulative effect over billions of years of tugging on the oceans. 40 feet in Canada, or 480 inches. What's the change from all the planets in alignment? And I'm just going to use both forces. Gravitational pull, 8 inches. That's if you could line them up. What about tidal force? 0.7 millimeter. What about the average height at coastlines around the world? Well, it's about 3 feet or 36 inches. So what's the change from all the planets? 0.6 inches. What's the change from tidal alignment things? Tidal forces? 0.052 millimeter. What about the effect on the Earth? People were complaining about earthquakes going to be started. It's 15 inches total dynamic caused by the moon and sun. What about from all the other planets? Quarter inch. What about tidal force? 0.022 millimeters. When do these alignments have the ability to happen? Actual alignment timing is every 400 billion years. It hasn't happened once, but if you want to change your definition of it, it's every 1,500 years. And won't happen for another couple of hundred. Anybody telling you otherwise is relying on the 40-year alignment that's in the sky that has no gravitational effect at all. Thank you for watching. Have a good day. Good luck with that.